this video, we are going to talk about something that we have been talking about in the last few videos, the POS. Yeah, we are going to talk about the POS form of expressions. Okay, so what is POS? Product of sums. Okay, we have talked about sums of product form, and now we are talking about sum of products form, and now we are going to talk about product of sums. Okay, so what is product of sums? This is when you give an expression as product of sums. Okay, so inside the parenthesis, we will have the sum of signals, and it will be connected by using AND gates. Okay, so when we were speaking about SOP, it looked like this. Okay, we had the product of signals. Okay, we had the product of signals, and the OR gate combined different products. Okay, the OR gate combined different products. This was SOP. This was SOP. So what is POS? It's the reverse of the roles are reversed. That's all. Okay. In POS, what happens is we have the parentheses work like that. Okay. Parenthesis has nothing to do with. Instead of using the dots inside the parenthesis, we are going to use the OR gates. So it will be A plus B plus C into A plus B bar plus C. Okay. So if you see here, here we had the AND gates as products of signals, and then they were connected using an OR gate or multiple OR gates. Okay, but here we have the OR gates inside the parenthesis. Okay, OR gates inside the parenthesis, and these sums are connected by using AND gates. Okay, so this is an example for POS expression. Okay, this is an example for POS expression. Let's say we have something like x is equals to a plus b into a bar plus b bar. Okay, so if you see here, this is a sum. Okay, and this is another sum which are connected by using an AND gate. Okay, so the expression is actually a single product. If you consider this, it is a single product. Okay, it is a single product. It's a single product. There are multiple parentheses. Product of different sums. Each parenthesis represents a sum of its own. Okay, so this is what we call product of sums. Okay, so let's look at another example. Let's say we have y is equals to a plus b bar dot a plus c dot b bar plus c bar plus d bar. This is another example for POS expression, an expression in the POS form. Okay, so why do we need this? Well, there are mainly two applications. One is when we are talking about max terms, which I will teach you in few videos ahead. And then we need this for when we are using NAND gates to represent different expressions, representing the expression only using NAND gates, which we will cover in the future videos. Okay, so these are the two applications. So as we studied in SOP, here also you have to keep in one thing in mind, that a single bar cannot be drawn or extended over more than one signal. Okay, so let's say we have something like this. So let's say Q is given as A plus B into A plus B whole thing bar. Okay, so if it is given like this, well, this is not in POS form. Okay, obviously this is a sum. Okay, this is a sum, and there is an AND gate, but this is not a sum. A plus B whole thing bar is not in POS form. Okay, but A bar plus B bar is actually in POS form. This is in POS form. Okay, this is actually in POS form. That's fine. Okay, this is in POS form, but this is not in POS form. So we have to change it to proper POS form if we are doing calculations. Okay, so that's what we are going to learn now. Okay, how can we do that? How can we convert this into POS form? Very simple. Just break the bonds. Okay, as we talked in De Morgan's law. So this is A plus B. That's perfect. We don't have to change anything. Dot. Instead of A plus B whole thing bar, we will give A bar dot B bar. Okay. But when you are giving this, you have to keep in mind this may look like a single product. Okay. So try to break it down. Okay. Like this. So you have A plus B into A bar into B bar to show the difference properly. Because A bar can be considered as sum, okay, can be considered as sum as well as product. Okay, it can be considered as sum as well as a product. Okay, so this is fine. This one is now in POS form. Okay, this one is in POS form. Let's say we have something like Z. Yeah, let's say something like Z is there. So let's say that is given as A plus B plus C into A plus B bar plus C bar whole thing bar. Okay, B bar plus C bar whole thing bar into A plus C plus B bar whole thing bar. Okay, so this is what we have. Let's say this is what we have. What should we do here? Well, here you can clearly see there are 2 points where the the point product of sum is not followed. Here we have an irregularity. Here also we have an irregularity. So we have to break them. Okay. So we have to break them. So if you break it down, so A plus B plus C, that is perfect. We don't have to change anything. It is a sum, so we can have it. Now we can break this down. Okay. So if you break this down, what will you get? You will get B double bar dot C double bar. Okay. You will get B double bar plus C double bar dot. I'm going to break this also. So I will get A bar dot C bar dot B double bar. Okay. And we know double bar or double complement means we can remove the double bar. So that will be given as A plus B plus C into A plus B dot C into A bar dot B dot C bar. Okay, I will just change the order according to the commutative law. Fine. Now, here we have B dot C. Okay, here we have B dot C. We can't have product inside the parenthesis in POS form. So we have to break this down. Do you remember something we learned in distributive law? That A plus B into A plus C can be given as A plus BC. Do you remember that? That's what we are going to reverse here. That's what we are going to reverse here. How are we reversing that? Well, this is all. We have A plus BC. Okay, we have A plus BC. Here we have A plus BC. So we will just write it down as A plus B dot A plus C. That's all. So this will be given as A plus B plus C into A plus B into A plus C. Then you just have to break them down single terms. Yeah, single signals. Why? I told you we can have like this, but not like this because this is misleading, but this is clear. So we'll do like that. So this will be A bar dot B dot C bar. That's all. Pretty straightforward. Yes. So this is how you have to remove the irregularities. If you have the bar symbol, okay, if you have the bar symbol or the negation or the not symbol, whatever you want to call it, if you have it over more than one single term, you have to break it down. Okay, you have to break it down. That's all you have to do.
Thanks for watching the 14th video in our Logic 8 series. If you found this introduction to POS and the techniques for converting expressions into POS form helpful, don't forget to like, share and subscribe for more lessons. Hit the bell icon to stay updated with our latest videos, check out the full playlist to master Logic 8 and follow us on Instagram. I will see you in the next video. Until then, keep learning and stay curious. Bye-bye.